Perfect. Aria is a 1958 composition by John Cage. The work consists of 20 pages of abstract lines, colors, and disjoint lyrics across languages like Armenian, French, and Russian. The notation is as absurd as it is subjective, and the result is a piece of music which no two performers will ever interpret in the same way. Included with the sheet music are these instructions, and for every aspect of the song they specify, they intentionally leave just as many open and freely determined by the singer. With music like this, Cage pioneered an approach that he called indeterminacy, which he defined as the ability of a piece to be performed in substantially different ways. For him, this often meant presenting a performer with the rules guiding the creation of a score, and then allowing the performer the freedom to execute those rules in a multiplicity-producing act of creativity. This approach shows up again in 1958 with a piece titled Variations 1, dedicated to a fellow musician named David Tudor. This was the first of a series of works centered around the use of transparent sheets. By overlaying these sheets together and interpreting the result according to the provided rules, new variants of the same piece could be constructed and performed by the musician. The space of possible music was still limited, though, and the fixed number of valid configurations meant that only a relatively limited number of performances was possible. Cage responded to this limitation in 1961 with Variations 2. This time, the transparent sheets could be arranged in any manner whatsoever, with the new set of rules generating an infinite number of possible realizations of the score. James Pritchett, a scholar of Cage's work, wrote that Variations 2 was a piece of music in which any series of actions in any order and combination whatsoever would lead to music. When David Tudor realized the piece later that year, he did so using a custom amplified piano that unified piano and electronics into a new style of music that contributed to the foundations for what became electronic music. Cage's avant-garde approach was wildly influential in other ways too, though. And in 1959, Silvano Bussotti composed 5 piano pieces for David Tudor. Bussotti was responding to a movement known as atonal serialism, a strict formalism which severed musical elements from any continuous and meaningful context, instead seeking style through mathematical purity. With Bussotti's aserialism, he aimed to infuse the avant-garde music world with the intimacy and the subjectivity which serialism had sought to avoid through impersonal rationality. And David Tudor was the instrument he intended to use to do so. Rather than being a dedication, the title of this piece referred to David Tudor as the instrument for which the piece was composed. Tudor was a talented improviser, and through him Bussotti hoped to bring about a type of music characterized by the joint participation of performer and composer in an effective intersubjective event. It wasn't what I had it in mind when I wrote this talk, but experiencing David's live coding yesterday and then hearing him talk about his performance of Damon brought to mind similar themes. And that's been a pattern through this entire week. I've given a lot of talks over the last 2 years, and I'm used to being the chaotic and weird trans woman who comes up on stage and then rambles about philosophy, art, and type theory. And I'm still going to do that, but it's just been so incredibly cool to be speaking at an event where that's what nearly everybody is doing in some capacity. Anyway, I'm Quinn, and I'm here to talk about Rhizomatic systems, decentralized data, and a local first database that I've been working on named Rhizome. I presented a draft of this talk for my team last week, and in an ensuing discussion about decentralized moderation, my colleague Blaine said something that I loved. I think really what Quinn is trying to do is argue against the idea that it's our responsibility to solve these problems on behalf of the rest of the world. And that's exactly it. The world is infinitely more diverse and more complex than any of us can imagine. And I think the way we build systems needs to reflect that if our systems are to benefit the people outside of this room, and if we're to avoid being condemned to the cycles of punishment that Jen warned us about yesterday. Rhizome is essentially my attempt at exploring what it means to build systems that abdicate our authority over those systems to the people using them. I'm an applied researcher at Fission, where I've been experimenting with new ways of building distributed systems. In my free time, I spend my nights tracing through the history of programming languages, trying to piece together the context that led to their development, and how the ideas behind them have shifted and morphed over time. One of my favorite parts of Jen's talk yesterday was the way she connected the history she shared with us with what was going on in her own life at the time. I won't be able to do the same since 1945 is a little before my time, but I'm sure Boris would love to regale us with tales of his childhood later. I have my own confession, though. In putting together this talk, I eventually realized that I'd need to define the word rhizomatic. And I tried, I really did. I've read so many books and scoured so many papers to look for a clear and concise definition of the word, and I don't actually know if one exists. Deleuze and Guattari introduced the word rhizome in 1,000 Plateaus, but they don't define it either. They let its meaning unfold over the course of almost 600 pages. That piano score by Busotti appears without explanation in the book. And I think part of the reason why is the way it hybridizes two different mediums, painting and music, into something that isn't quite described by either. So I'm going to try to do the same thing with this talk. I'm going to discuss a lot of things, and most of them are going to seem unrelated. But I hope that in their entirety, you'll begin to understand, if only just a little bit, why I chose to name a local first database Rhizome and what we're hoping to accomplish with it. But first, I'd be remiss not to give you a definition, so I'm going to start with the best one that I've encountered. The rhizome is a model of thought that defies the very idea of a model. It is an endless, haphazard multiplicity of connections, not dominated by a single center or place, but rather decentralized and plural. It is thought characterized by a radical openness to an outside. In this way, to be rhizomatic is to be non-hierarchical, to be dynamic, to eschew totalizing ideas and schemas, and to fully embrace heterogeneous connections. It was connections that Vannevar Bush was concerned about in 1945, when As We May Think was published. With World War II coming to a close, and with it his involvement with the Manhattan Project, Bush turned his attention toward knowledge itself. And in 9 pages that must have rivaled the science fiction of the time, he painted the soundtrack of a future inhabited by all manner of machines. Voters that could synthesize human speech, mechanical stenographers called vocoders to transcribe it, and cameras so tiny and so reliable that we'd begin chronicling everything. With so much information available to us, though, Bush foresaw a problem. How could anyone ever sift through such astronomical amounts of data? Existing solutions like automatic telephone exchanges selected records in an essentially hierarchical manner, by traversing down a tree of relays using the digits of a phone number. And I'm reminded of a letter sent by the Library of Congress to one Dr. Norbert Wiener in 1949. My dear Dr. Wiener, it begins, the publication of your book on cybernetics has caused the editorial staff, which is in charge of the revision of the Dewey Decimal Classification, considerable difficulty. Generally speaking, a book can only be assigned one number, and consequently, we cannot take care of the many aspects that certain works cover. The problem must be simplified. Is your book such as to place it in psychology? Does it belong to the field of electronic computation devices, or does it belong in mathematics? If we were not somewhat desperate about this particular problem, I should hesitate to bother you with it. As Vannevar Bush said 4 years earlier, the human mind does not work that way. It operates by association. It jumps from one item to another, following complex trails of connections between disparate ideas and memories. If we were to augment our mind with machines then, Bush thought we must mechanize this process of following associative trails. And in his mind, the way to do this was with something he called the memex. It's almost quaint the way it was illustrated at the time. A desk filled with microfilm containing all the world's information, and with mechanical levers meant to explore the associations between it all. But I think looking at the ads this visionary piece of writing was printed alongside gives some valuable context. This was a world where men feared the touch of metal from their garters, where Sir Walter Raleigh was no longer a fashion icon, where we'd yet to discover a cure for corns, and where people still thought you could make a business out of selling to-do apps. Some of this vision came to pass, and it's impossible not to see the memex in the world, in the hyperlinked internet that we have today, but aspects of its design were lost along the way. First, though, I want to talk about the opening sentence of As We May Think. This has not been a scientist's war. It has been a war in which all have had a part. It's obvious that he's referencing the atomic bomb here, but it's his allusion to the non-scientists that I find especially interesting. He doesn't expand on this point, but my mind goes to the way the arts were repurposed toward the war effort. On one hand, there's the Ghost Army, made up of people from professions like acting and architecture, and working in collaboration with Bell Labs to deceive the Germans with the improvised soundscapes of mock battles in the night. But artists across the Allied home front were also pulled onto a virtual battlefield, and one of those was Frank Capra, the director behind some of the most recognizable films of the 1930s. In 1941, after the attack on Pearl Harbor, Frank began working directly under the Chief of Staff for the United States Army, and he was tasked with producing propaganda films to counter those being used by the Germans. What came out of that was Why We Fight, a series of 7 films dedicated to revealing the depths of the evil incarnate in America's enemies. How he did this is interesting, though. With no team behind him, he had very little resources at his disposal to produce material of his own, and so he turned the propaganda of the Germans against themselves. Acting in direct response to the horrifying triumph of the will from 1935, Capra recontextualized his own footage into an attack on Nazi ideology, remixing films like it into something new entirely. So it's fitting that Capra's own works went on to experience a similar fate. In 1937, his Lost Horizon was released. The film was a financial failure and was panned as an incoherent mess. This wasn't entirely Capra's fault, though, and the film had been heavily censored, with critical scenes espousing pacifistic and utopian ideals being cut soon after release, and much of that footage being lost, presumably forever. It wasn't until nearly 40 years later, in 1975, that the film was restored, in a process that was described as doing a gigantic jigsaw puzzle, whose pieces were scattered all over the world. This same piece opens with a bold statement. If you think you've seen Lost Horizon, you probably haven't. Again, it's fascinating to me the way something so new can emerge out of the shuffling and remixing of largely what's already there and through the combined efforts of a globally distributed community. And Ted Nelson thought so too. In 1981, in Literary Machines, he wrote of the restoration process of Lost Horizon, using it as an example of what he considered to be a non-sequential editing process. These paragraphs appear alongside a description of zippered lists, a data structure he designed for storing alternative variations of documents. The idea was to support the horizontal linking of varyingly ordered sequences of items together, such that the connections and intertextuality inherent to most pieces could be made explicit within their representations as data. Inspired by Vannevar Bush, these ideas grew out of Ted Nelson's fascination with the problem of how to organize the world's information into one great repository, equally accessible to all, a network he called Xanadu. One important feature of his vision was the ability to construct multiple pathways through media for readers of different backgrounds and with different needs, so as to facilitate a multiplicity amplifying form of publishing and curation. This is a little bit of an abstract notion, but I've come across shadows of the sorts of ideas that Ted may have had in mind, and one of my favorites is Thomas Petracek's dissertation. His research was on a topic within programming language theory called co-effects, concerned with making programming languages context-aware. The theory behind his ideas is deeply rooted in type theory and mathematics, but he also experimented with the presentation of those ideas. And his dissertation includes an interactive tutorial that presents the user with a number of pathways through his research. In one section, he briefly gives an overview of comonads, quickly moving past the details. But for readers who love theory, this section is expanded, fully diving into all the math required to fully connect his application of the ideas to the foundations they build off of. The whole website follows this design, and I think it's a brilliant way of demonstrating the types of plurality that Ted Nelson was enthused by. The analogy still isn't perfect, though, because while Thomas Petracek is making visible different perspectives over his own writing, it's still just that, his own writing. And what Ted Nelson wanted was to enable the collaborative synthesis of hypertext, formed out of blocks from across the entire network, not just of writing, but of every sort of media and knowledge that could be processed and stored using a computer. To put a modern spin on Paul Klee, hypertext is an idea that's gone on a walk, and sometimes the best walks involve leaving your neighborhood. Here's an early video of Xanadu in action. I say early because this doesn't even show off the ability to link to links themselves, which was an essential part of the entire endeavor that hasn't really carried through to the web that we have today. I don't think it's Ted's fault that Xanadu has a reputation for seeming so complicated, though. In a chapter describing how to organize an interplanetary document store, he opens with a quote from a Werner Herzog film. "Our kingdom is already twice the size of Spain, and every day we drift makes it bigger." This quote is good, but if Literary Machines had come out a year later, I like to think that there's another passage he might have used to discuss the scope of what he was trying to do with Xanadu.
And we have to become humble in front of this overwhelming misery and overwhelming fornication, overwhelming growth, and overwhelming lack of order. Even the stars up here in the sky look like a mess. There is no harmony in the universe. We have to get acquainted to this idea that there is no real harmony as we have conceived it. But when I say this all full of admiration for the jungle. It is not that I hate it. I love it. I love it very much. But I love it against my better judgment.
This is really important, so I'm going to quote one part of that on its own. "There is no harmony in the universe. We have to get acquainted to this idea that there is no real harmony as we have conceived it." This is a scary thought to a lot of people. So I can understand why it sometimes feels like the entire history of computing has been a history of trying to paint over this fact. But I do think it is a fact. And I think our tendency to force the world into strict categorizations and hierarchies is a rejection of this natural disorder of things that serves to limit not only the resiliency of our systems, but also what we're able to accomplish in using them. I use the word resiliency there, though, and it's a word that I want to be careful with, because there's some subtlety to its meaning that we don't often talk about. I checked a dictionary, and it defines resiliency as the ability of a system to regain its original shape or function after being subjected to external forces or challenges. It's that focus on regaining its original shape that makes resiliency so dangerous. By expending so much effort ensuring that our systems are able to recover from stress, we at the same time prevent our systems from moving past those stressors entirely. Now, it's not that I'm arguing against promoting any notion of stability, but instead that I think there's an opportunity to pursue something stronger than mere fragility or mere resiliency. Anti-fragility, or the ability of a system to not just survive through volatility, but actually thrive and grow as a result of it. This is something we see all of the time in nature and in society, with humans and networked organizations engaging in tight feedback loops that allow them to react and route around emergent dangers. But the technology we build is often rigid and rarely versatile enough to keep up with us through these rapid changes. And this has profound effects not only on our ability to evolve systems over time, but also re-instruments those systems into tools for upholding the status quo and impacting our ability to enact further change in the world through our reliance on them. In one of my favorite books of 2021, Shannon Mattern talks about this a little bit and says that algorithms and interfaces tend to bracket out those messy and disorderly concerns that simply do not compute. Her argument is essentially that through our attempts at operationalizing smart cities through the use of digital dashboards, we lock ourselves into incomplete and dangerous models of the world that blind us from developing a rich understanding of our cities and the sorts of problems we're able or willing to solve within them. Christopher Meiklejohn makes a similar point, specifically as it relates to distributed systems. Here, he's claiming that real-world systems are fundamentally eventually consistent. They perpetuate themselves through the exchange of information in the form of letters, telephone calls, and writing. And so they must be resilient to this information being dropped, delayed, or reordered. To aim for a stronger sense of consistency in distributed systems is to go against this nature. He proposes that rather than targeting global consistency with some primary node, systems should instead be built to treat the local knowledge recorded at each node as being an accurate reflection of that node's view of the world. He argues that to do otherwise is inherently limiting, but claims these designs are common because of the way they simplify the use of existing tooling. Here we have another example of our limited tooling limiting our understanding of the world. He then goes on to briefly acknowledge the incompatibility between the designs he's criticizing and the constraints of peer-to-peer networks and large-scale edge computation. There, rather than one globe-spanning network, we end up with a number of smaller, sometimes overlapping networks, computing over different slices of the total set of data, with no guarantee of ever achieving or even desiring system convergence. If I were to give a name to what he's talking about, it'd be something like, I don't know, causal islands, maybe? Conceptualizing of systems in this way fundamentally changes the assumptions that we can rely on in building them. Rather than designing arborescent networks with static topologies routing through centralized services, we end up with non-linear rhizomatic architectures, where nodes are born, form arbitrary connections within the network as they live out their sometimes brief lives and then die in often unpredictable ways. And engineering for such a world means giving in to the harmony of overwhelming and collective murder. With enough engineering effort, our existing tools and techniques may allow us to survive in such a world, but if we're to truly thrive and build anti-fragile systems that take advantage of the untapped potential available to us, then we need new ways of thinking about distributed and decentralized data. That's the idea behind disorderly programming, a term that was coined by the team behind the Bloom programming language back in 2011. Bloom was an experimental language meant to explore the use of a high-level declarative programming language for building distributed systems. Under the hood, its semantics are based on a deductive query language named Datalog that's historically been used for reasoning about relational query languages. It essentially works by traversing the associations that exist between different entities in order to solve for logic variables and answer queries about the resulting trails. Bloom was named after Leopold Bloom from Joyce's Ulysses, and I like to imagine the language as the personification of the Memex, ambling through Dublin and following a stream of consciousness flow of associations linking the memories scattered throughout the city. But Bloom was preceded by an earlier language named Daedalus. Also out of Ulysses, the name also evokes the great maze builder of antiquity. In The Idea of the Labyrinth, Penelope Dobb writes that what you see depends on where you stand. And thus at one and the same time, labyrinths are single and double. They simultaneously incorporate order and disorder, clarity and confusion, unity and multiplicity, artistry and chaos. They are dynamic from a maze walker's perspective and static from a privileged onlooker's point of view. In a distributed system, though, there is no privileged position. The maze is always dynamic, always changing, and every node's perspective is one formed out of incomplete and local information. But it's this indeterminacy that Datalog can cut right through. The big insight that makes this possible is the COM principle, consistency as logical monotonicity. The COM principle gives a correspondence between the family of eventually consistent programs with coordination-free execution strategies and monotonic logic, Datalog. Informally, not only is any program which can be expressed using a monotonic subset of Datalog guaranteed to be eventually consistent in a distributed setting, but there also exists an embedding of every eventually consistent program in monotonic Datalog. One simple correspondence is able to capture the precise power and semantics of a distributed programming paradigm that entirely avoids the use of distributed locks and consensus and all of the other coordination protocols we rely on. It's sort of like Cage's Variations 2, by changing the rules, he was able to devise a game that wasn't susceptible to order, time, or conflict, and instead always allowing music to bloom. It's these ideas that Rhizome builds off of, to expose a query language that supports eventually consistent views over disparate data sources, like encrypted stores and IPFS. In Rhizome, data is encrypted as 4 tuples, specifying an entity, attribute, value, and any causal links. These causal links denote the provenance of data and reference other tuples using content IDs. This is a little hard to read like this though, but because these are SIDs, the dependencies are guaranteed to be acyclic, and so we can visualize the database in a form that should be more familiar to us. A directed acyclic graph. Thanks to the common principle, by using a query language inspired by Datalog, we can traverse this graph and interpret its structure as an eventually consistent CRDT. In this case, it can be viewed as an observed remove set for a set containing the letters D and C. But because we use IPFS to derive content IDs for data, we can also guarantee that these CRDTs are Byzantine fault tolerant, which means that we're able to support multiple writers, including in trustless environments. Rather than writing data to a shared store, we essentially query over the union of potentially many single writer stores, each potentially containing horizontally linked tuples spanning multiple stores. Due to the convergent nature of CRDTs, this means that different readers may subscribe to different writers, but in a way that guarantees monotonic progress towards some result. This is what enables us to provide every device on the planet with its own database, and allowing those devices to collaborate in locally meaningful ways. In practice, I've been doing this by layering Rhizome on top of Fission's IPFS-based file system, and associating an append-only log of tuples with each device. Soon, this will happen directly over Merkleized data structures, and an interesting research avenue would be to explore the use of Crawley trees for performing range queries over remote data. I haven't implemented it yet, but we also have a design for querying over encrypted data, where certain readers may only have access to certain other writers. In this example, the reader doesn't have access to the decryption key for the gray events, and so it's unable to satisfy the causal links for any of their downstream dependencies, and so the resulting set only contains the letter D. In a sense, we treat encrypted data as a special case of network partition, where rather than some of the data being unavailable due to network failure, it's unreachable as a side effect of not having been granted the required keys. What makes this design special, though, is the way the partition can be healed and convergence restored if the required keys are ever shared with the unprivileged reader. There's other reasons a reader may transform the resulting data, though. And in this case, a reader might want to revoke all of the blue events and end up with a CRDT that's consistent with respect to all other events. This is happening entirely at query time, though, which means that different readers can impose their own constraints on the data. Perhaps I don't trust some writer, and so I don't want to honor any rights that depend on his. Or maybe I subscribe to a fact-checking service that annotates news stories with a trustworthiness score that I use to dynamically filter out non-reputable stories. Or maybe I subscribe to a feed of crowdsourced content warnings that I can filter and overlay onto the content that I engage with. By content addressing all of the data in the system, we gain the ability for anyone to extend any of that data in arbitrary ways. Just as Ted Nelson supported attaching links to links, we're able to associate facts with facts. And with that comes the capability of reshaping our understanding of that data in very metacircular ways that facilitate evolving our ability to harness that data over time. This goes so far as allowing for a total reinterpretation of data. In the simplest case, this set could also be interpreted as a counter by viewing additions and removals as increments and decrements. In this way, agents can repurpose pieces of a graph as different types of data, even annotating that data with additional fields or metadata for their needs. In the case of a collaborative text editor, this might mean prioritizing your own rights over another user's while managing conflicts, and allowing them to do the same. As in the case of Busatti's composition, the interpretation of the data depends just as much on its reader as it does the agent who wrote it. This is only an idea we're beginning to explore now in software, with the sorts of bring your own algorithm approaches that protocols like Blue Sky are starting to experiment with. But I honestly think it's one of the most exciting possibilities available to us in terms of shifting agency back into the hands of the people that we're building software for. And autonomy is one of the driving motivators behind local first software, a recent paradigm coined by Ink and Switch in 2019. It defines a set of guiding principles for building software that prioritizes user privacy, security, and agency. Most of you have probably heard all of this already this week, though, from other talks here, and I just want to take a moment to call out how incredible that is. I've been talking about local first software at conferences for over a year, and I'm used to being the only one up on stage pushing these ideas. But Causal Islands has been different, and it's kind of surreal and exciting to me just how many people here already share most of my own personal vision for where computers need to go. Anyway, the dream of local first software is of a world that empowers people to take back ownership of their data, freeing it from the tyranny of the cloud and of the centralized services that comprise it. In local first software, a user's device is the central source of truth for them, with data all being stored locally and with a hard dependency on the network being severed. Instead, local first software embraces eventual consistency, and it makes use of techniques like conflict-free data types to synchronize data between devices. It's exactly this niche that Rhizome is being built for, and we have a working prototype implemented in Rust that compiles down to WebAssembly to run in a browser, or to native code for backend and desktop deployments. It's still a work in progress, but we did just open source the repository just a few days ago, and my immediate focus once I get back to California is going to be on making that early version more usable to anyone else, so adding docs, examples, and opening the door for community contributions. After that, the roadmap includes adding support for querying over encrypted data, building out a library of CRDTs, and integrating with some common front-end frameworks like React. I do also have some early prototypes that demonstrate automatic incremental view maintenance using some data flow-based approaches that let us efficiently query over dynamic streams of data. So if any of this is interesting and you want to help out with it, just come and find me later. But with that being said, let's see a demo. So I like movies. How many of you have used Letterboxd? Awesome. For those of you who don't know, it's kind of like a social network for movies. You post reviews, take movies, etc. So I used Rhizome to make Sweaterboxd. It's basically Letterboxd, but for cozy movies, for cozy people. There's not a ton going on here. We have a list of movies. They have images, titles, release dates, etc. But it's all implemented using Rhizome. So all of the pieces of information here are small atomic facts about the domain models that we're displaying. And all of them are being stored in a content-addressable way that we're able to synchronize and persist between devices in an eventually consistent manner. So let's modify the state. I have a little toggle up here where we can switch between comfy, screwball, and whatever John is. I talked a little bit about bringing your own algorithm, and this is kind of a small contrived example of what that sort of thing might look like. All of the configuration and rules for filtering and tagging things and the UI and so on is actually stored in the database as these Rhizome facts and rules that work essentially like data log. So if I click on Screwball, for example, we're now on Hotboxd for high culture. And the application state is actually being stored as a content addressable last writer wins register. So all of this is being content addressed and persisted. It can be replicated between devices, eventually consistently synchronized, and so on. And basically, that state is being embedded as one of those causal DAGs that I was showing a few slides ago. So if we go down here, you'll notice a hash. And this is actually a hash of the application state that corresponds to the fact that represents where we are in that causal history. So what this means is that we can actually time travel through application state, kind of like if you've ever seen like the Elm time traveling debugger. But I wanted to take a look at this last toggle. I talked a lot about John Cage earlier and how influential he's been to so many different people in the art world. And Cage has also been a massive inspiration to me, which is why I wanted to make Letter Caged, Unleash Film. We've got Con Air here. It's one of my favorite movies. There's also Adaptation, which I really wanted to work into this talk because I think it's the most Rhizomatic and Deleuzian movie I've ever seen. And working on this talk, I actually read 2 academic papers exploring the Deleuzian philosophy of Charlie Kaufman in Adaptation. If you haven't seen this movie, give it a look. It's fucking wild. But I know what you're all thinking. I'm talking about bringing your own algorithms, and I'm just switching between preset options right now. That's not super interesting. We've been able to do that for a long time. So let's do something more fun. Who knows the Konami code? All right, scream it out. Up, up, down, down, left, right, BA. Oh, wow, there's a prompt up here now. That's fun. So this, let's see if this works. I hacked this in Tuesday night after seeing Jeff Litt's talk with Potluck. At one point in the Q&A, Jeff talked about how he wasn't sure if JavaScript was the right language to generate using LLMs. And it reminded me that I have actually spent quite a bit of time using LLMs to generate data log and Rhizome rules and things like that. So I thought it might be fun if we went through Bernstein's marketing exercise together and kind of came up with some branding guidelines for what sorts of movie sites we want, what sort of movie site we'd want. So people just start screaming out what type of movies you like. Superhero. I heard another one. Adam Sandler. Anything else? New Wave. All right, now someone scream out something abstract, like a mood or something you're going for. Alienation. Okay, so let's say like comedic alienation in the world of film. All right, now we can hit submit. And now I want to take a moment to address the basilisk in the room. So I'm going to cover this up for a second. You probably saw that it opened up and said praying to the demo gods. That's not actually me being concerned about whether the software is going to work, because it does work. There's something else that I'm worried about, and it showed up last night when I was going through this code and making sure it worked. I asked for campy Nicolas Cage movies, forgetting that he was in a trailer for a movie called Nazi Werewolf Women of the SS. And so when the result came back from the LLM, suddenly there was a giant swastika on my page. So last night I frantically added in some ad hoc filtering to try to stop that sort of thing from happening. But I just want to caveat whatever we're about to see with the warning that using LLMs for parlor tricks is all fun and games until you accidentally project hate speech in front of a whole room of people. All right, awesome. So we have Super Sandler Wave, where superhero Sandler and New Wave collide with laughter. Pineapple Express, Grandma's Boy, and Harold and Kumar. Great. That sounds exactly like what we were looking for, actually. So one other fun part about this is that essentially what happened there is we used the prompt to tell a LLM to generate a bunch of Rhizome queries corresponding to what we were looking for, and then also go through the database and take those with the relevant features. And the reason I did that up here is because I really wanted to show this sort of bring your own algorithm thing, but it's not super interesting if I stand up here and write data log in front of all of you. And I really liked Jeff's point about how if we really want to empower people to truly modify and extend the systems that we're giving them access to, they need to do so in ways that don't depend on them going through a bunch of first-order logic papers from the 80s. So I'm not saying LLMs are the way to do that, but that was definitely easier than the current DSL that I'm exposing for the thing, so I'll take it for now. The other part I want to point out, though, is that all the work that happened with that LLM is now in the database. It's persisted, it will replicate, synchronize, etc. And so we can go through this history, and all that's being tracked down here, time traveling, blah, 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 kind of fun. Let's do something. So I'm going to click screwball, going to go back here, going to go to John. Now if I hit previous, hit previous, now hit screwball, hit previous. Oh no, there's no next button, there's a conflict. There's two possible next revisions for the CRDT, and it doesn't know which one to pick. I didn't get far enough to actually implement this aspect of the demo yet, but essentially, because all of these queries are happening at read time, you have the option of controlling how that conflict resolution happens and allowing people to decide how they traverse through history when there's different conflicts. And this is a very cool capability. It's also a very difficult thing to expose to users. Jeff actually has a paper that I absolutely love from last year called Merge What You Can, Fork What You Can't, that explores some of this design space. I really recommend taking a look. But yeah, that's a kind of the demo for Rhizome. So let's pop back to the slides. The slides are gone. Cool. So I want to step back a little bit, though, because I didn't just come up here to talk about Rhizome, because I think the ideas that we're pursuing go beyond local first software and permeate into how we should be thinking about decentralized and distributed systems. In 2002, David Weinberger wrote that the internet forms the only persistent public world that accumulates value with every interaction. He described it as a world that we build simply by using it, where what is of worth stays and adds to the web's overall worth. I think that may have been true once. And I sometimes see traces of that early idealism showing through the cracks of what we have today. But when I look around now, I see a web that's largely one of decay, disempowerment, and fragility, where something as profoundly simple as a hyperlink can't be relied upon to work for longer than a few weeks, where whether we're allowed the dignity of 80 characters or 4,000 is at the discretion of a billionaire we'll never meet, and where our access to critical information is gatekept behind APIs that can be pulled out from under us without warning. But when I say this full of admiration for the web. It's not that I hate it. I love it very much, but I love it against my better judgment, because I know just how much richer it can be if only it's able to fully respect and embrace the collective intelligence of the people it purports to serve, by trusting in the stigmergic capabilities of those people to bring about a spontaneous network beyond anything anyone in this room can design themselves. I truly love the web. And as a trans woman who grew up on it, it has fundamentally shaped who I am and given me access to so many connections and so much information that I have needed to make it to where I am today. But I've also seen the ways in which our technology can serve to silence voices less privileged than mine. And I want to make sure that it's the positive experiences that I've had that are carried through and shared by future generations. Busatti's music wasn't merely a response to serialism, but also to a world that oppressed his homosexuality in the same decade that it killed Alan Turing for his. And Paul Klee's artwork wasn't just an exploration in surrealism, but also an anti-fascist critique of a world that he knew could be better. I'm not saying that Rhizome solves all the web's problems, but I think it chips away at some of them. And I think that all of us here in this room are uniquely positioned to chip away at some of the others so that we can do our part to reshape the web into a world that we're proud to inhabit as our own by empowering everyone in that world to do the same. I want to be very clear, though. I am optimistic about the future. I touched upon anti-fragility earlier, and humans are remarkably anti-fragile. And human history is a story of thriving in the aftermath of adversity and repression. My question to all of you isn't whether we're going to make it through whatever the future has in store for us, but whether the systems you build are going to amplify our collective intelligence and help us through whatever is ahead, or apt to slow down our inevitable triumph. I'm Quinn, and thank you so much for giving me an hour of your time here. It has been such an honor to meet you all this week.
First off, that is a lovely talk. I love the art. I feel like that's something I miss sometimes from programmatic spaces. So I love the deep dive into art history. I also want to share, Sarah, I share your vision. I share your view on the future, but I noticed a contradiction in the talk that I wanted to dig into a little bit.
Okay.
Um,
I almost made a joke about how this corner of the room is vicious.
oh, always. You mentioned the Werner Herzog quote about how there is no grand harmony and there is no whatever. But then 5 slides later, you reveal a grand harmony to us. The truth, the mathematical fact that monotonically growing systems can be organized in this way, that this massive complexity of the Rhizomatic system can be engaged with in this specific way and can be harnessed with this, and its full power displayed. So what's up? What's going on?
So I want to be careful with my words, because everything I'm saying with data log and with the comp theorem isn't about saying that it enables a sort of harmony that is universally applicable, but more about finding where the limits of such a harmony can be, so that we know where the possible space is for us to operate within, and so that we can maximize our ability to build these systems that evolve in response to the pressures that would cause a more rigid system to fall apart. Does that make sense?
Yeah, I think it does. I just, I'm not quite sure what the difference is. Like, it seems like to be artistic for a moment, like grand symphony underlaying the massive disorder, you know?
I think for me, it's about either having like the arrogance to think that you can ahead of time design and understand everything that a system is going to need to do in order to succeed, versus acknowledging that there's always going to be limitations in any models that you build, and that those are going to need to adapt to like emergent changes in an incredibly dynamic, like larger system that you're operating within.
I'm actually really curious about what sort of data log query got generated by the language model. Is there any way we could peek?
Unfortunately, no. The JavaScript bindings only started working in the course of me putting together this demo. Okay. And I don't have enough debugging capabilities available right now. I could probably output a list of which movies were being tagged, but I don't have a great way to reach into the VM right now with the JavaScript streams that I've had together over the last couple of days, mostly because everything's happening inside web workers through a really convoluted like FFI thing between like JavaScript and then comlink and then web workers and then WebAssembly that's been generated through Rust. So there's a lot of cleanup that needs to happen there to expose a lot of the stuff that currently exists on the Rust side of things.
Would it be possible to go in the network tab and get like the AI or the language model output?
Yeah.
Or would that make sense?
That's a good idea. So it's returning a bunch of the entity IDs in the movie or in the database that correspond to the movies that it tagged. Those are going to correspond to facts that are like roughly and then a map of the SIDs. A map of the SIDs that correspond to whatever is being annotated, so you can track the provenance of that data. But that's happening in JavaScript right now based on the output that came back. This is just really rough hacked together, like half-hour integration though, so there's a lot more that can be done there. In building Rhizome, I've been having a lot of success with using GPT-4 to do things like write tests for me in the language that does not exist anywhere else, telling me about like usability problems in some of the features, porting programs from other languages to Rhizome so that I can test them out and stuff like that. And it's been working shockingly well. One of the really nice things about Datalog is that its semantics are so constrained that you don't really need to be concerned about anything bad happening. If there's a bad program, it's not going to run forever. Everything's pure. Most things are monotonic, and where there is non-monotonicity, you can statically determine that ahead of time. So it's honestly a really safe system for you to just generate what's potentially malicious garbage and run it and see what happens, as long as swastikas appearing on your screen aren't in your threat model.
We have another question over here.
I just noticed you had a text file containing the list of ethical billionaires.
Oh, yeah. Well, so it's 0 bytes.
So we have a question from the Discord, actually. How will the CRDT be replicated across all the nodes? Will there be multiple different CRDTs that work together?
So this is one of the really interesting things. It's not going to be replicated to all of the nodes. Every node has its own single writer store that is... This isn't enforced by the system. You can integrate this however you'd like. But the way things currently work within Fission's IPFS file system stuff is that every Fission account has its own file system that is essentially a Merkle DAG. And then they can create a tuple store at a path within that file system. They can share that path with anyone they'd like to share those tuples with. And then we track the revisions of that file currently using DNS link, basically just pointing the head or pointing DNS record at the current head of the file system in the content addressable storage layer that we're dealing with. And then a given device will pull down some number of tuple stores. And because everything is convergent, commutative, associative, etc., that can happen in any order. Data can be lost, reordered, etc. And you're always going to end up in the same spot. So if you have a CRDT that is made up of tuples from 2 different writers, for example, and then I have a device that is only pulling from one of those, there may be tuples that are missing that would cause the resulting DAG to be incomplete. But because of the monotonicity, the interpretation of that DAG would also end up in a partial state that could be reconciled as more data comes in, either as they gain access to more tuples or as they discover more nodes on the network, whatever. But kind of the way that I have been thinking about this stuff a lot is that rather than trying to have like a global DHT that everyone is pushing facts into, you're building smaller localized communities over shared interests or like different geographic regions and so on, and then building those trust relationships socially to decide how and what gets shared.
Anyone else with a question? Okay. Thank you, Quinn. That was awesome. Thank you so much.